Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss phenol formaldehyde polymer, also known as bakelite. And after that also I will discuss melamine formaldehyde polymer, copolymerization and rubber. Okay, these things today I will discuss. Last class I have discussed low density polythene, high density polythene, Teflon, polyacrylonitrile and polyamides. Under that I have discussed nylon 6,6 and nylon 6. Also I discussed polyesters. Okay. Now I am going to discuss phenol formaldehyde polymer, also known as bakelite. Phenol formaldehyde polymers are the oldest synthetic polymers. These are obtained by the condensation reaction of phenol with formaldehyde in the presence of either an acid or base catalyst. Actually, under condensation, I have discussed many you can say polymers. Correct? Means pterylene or dacron, that is coming under condensation polymerization or step growth polymerization. Polyamides also coming under that. Means nylon 6, nylon 6, polyesters, all are coming under that. And this also phenol formaldehyde comes under condensation polymerization. Then phenol formaldehyde polymers are the oldest synthetic polymers. These are obtained by condensation reaction of phenol with formaldehyde in the presence of either an acid or a base catalyst. The reaction starts with the initial formation of ortho or para-hydroxy methylphenol derivatives, which further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product could be linear product, that is called Nova-Lect, used in paints. Nova-Lect is used in paint. Then initial product you will get Nova-Lect, N-O-V-O-L-A-C, Nova-Lect, N-O-V-O-L-A-C. Correct? Then here you require that phenol and formaldehyde. Two things is required here. And other things what is required? Then either acid or base. And reaction starts with initial formation of ortho or para-hydroxy methylphenol derivative. You will get first this product, and this further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product I told you will get Nova-Lect, used in paints. Reaction I am telling you, phenol plus HCHO, that you can write as a CH2O also. Same things. HCHO or CH2OH, same things. Then here this reaction will take place in the presence of H or H plus means acid or in the presence of OH minus means base. Then what will happen here? You will get CH2OH means in phenol plus CH2O was there, that will join with alpha carbon means ortho position it will join, and you will get CH2OH. How will you get? Then in benzene at ortho position, hydrogen is there, benzene ring is there, then H will be there on each carbon. Okay, because alternate double and single bond is there. Then now at the carbon H is there, that bond will break. Correct? Then that will get H plus and carbon will get O negative. Then here oxygen is electronegative. Then here actually that H plus will join to O, oxygen, correct? And carbon CH2O, then that C will join, which is negatively charged, which is positively charged, will join with a negative carbon. Because C and H bond of benzene that broken, it gone as a H plus, then C became negative, and here CH2OH, no, that in HCHO, CHO aldehyde group. Then here that this actually CH2OH, that CH2O will join with carbon, because this carbon will be positive, CH2O, that carbon will be positive and that carbon is negative, correct? Then that carbon will join with CH2O and O will be negative, electronegative. Then that H will which gone from the benzene ring, that will join with O. Then you will get CH2OH. Okay, aldehyde, you know that carbon and oxygen double bond is there, correct? Carbon and oxygen double bond is there, C and O, between C and O. Then that actually breaks, one bond breaks, then O will be negative and carbon will be positive, correct? Then that O negative, H plus from the ring, that H came, that will join with O and it will form OH. And carbon is positive, that carbon will join with negative carbon of benzene, correct? Then like that way we will get the product in phenol now CH2OH attached. Then this CH2OH can attach with ortho also, para also, and if aldehyde is more, then it can join to the this also sixth carbon means the next side, ortho, meta, para, correct? Para again, after the para again meta will get, then ortho will get sixth carbon. There also it can join, correct? Ortho position, after that this para position, and then again sixth carbon, there also it can join. Three possibilities are there. Then first product you will get at phenol is there, but in that benzene In that ring, CH2OH will join at ortho position. Other product you will get, in that you will find that ortho and para, both position is joined by CH2OH. CH2OH will join at ortho position and para position also. This is the second possibility. Third possibility is that now 3 CH2OH will join, one at ortho position, other with para position, and third one again with ortho position, means 6 carbon. Here 3 CH2OH will join. This 3 product you will get. All 3 product you will get. Okay, this is actually called para. When it will join with para, then it will be called para hydroxy methyl phenol derivative. 3 derivatives you will get. Okay, para hydroxy methyl phenol. Okay, and this you will get in the first stage. You will get these 3 products you will get, and this initial product what I told is actually Novo-Lect used in paints. Now here you can see what will happen, that if you will take n number of hydroxymethyl phenol, if you will take n number, then what will happen means that phenol is there, in that CH2OH is attached. Suppose that is n number. Then in presence of OH means base, OH plus you can tell. Generally OH will be minus, but here you have to think OH plus. Then how will you get OH plus? That is a question mark. Generally that is the OH. H2O, H plus will go, then you will get OH minus. And now here I am talking you that in presence of here OH plus. Then how will you get these things? Then here you can think oxygen is electronegative, lone pair of electron is there. If this electron it will lose, then finally OH will be called OH plus. Then now suppose n molecules you have taken hydroxymethyl phenol, first product. Then what you will get here, that OH will join with H plus. Okay, I told you this reaction will take place in presence of both H plus or OH minus. Then OH CH2OH, that OH, it will come out as OH minus, and from the acid H plus. Correct? From the acid H plus, then OH minus H plus. Correct? That or you can understand that because n number of hydroxymethyl phenol is there. Then now suppose that first to consider that 2 are there. 2 are closed. 2 molecules are closed. Then what happened, that this hydroxymethyl phenol, correct, that in on each carbon one hydrogen is there, that you know, correct. All carbon has H. Then if 2 molecule will come, hydroxymethyl phenol, if 2 molecules will come together, then H from the benzene ring, CH was there, that H, and OH from the hydroxymethyl phenol. or para-hydroxy methyl phenol, that OH and this H plus, that will form water and it will go outside. Then that carbon, one carbon is negative, H plus went, then carbon became C plus, C minus, carbon became minus because H gone has H plus, and OH gone as OH minus, then carbon will become negative, then negative and positive both will join, then between the two rings CH2 will come. CH2, OH was there, OH gone, then this CH2 joined with the other ring, correct? Like that way, if third will come, third hydroxymethyl phenol will come, then same thing will happen. H and OH will go as a water molecules, and both third and second will join with, it's through the through CH2. Like that way it will be long chain. You will get a long chain, correct? Then this long chain, this product is called actually Novo-Lac, correct? Novo-Lac. Then I told you, first from the phenol and aldehyde you will get hydroxy methyl phenol derivative you will get, and after that which further react with phenol, to form compounds having rings joined to each other through CH2 groups. Okay, then initial product I told you, you will get Novo-Lac. Then now you got the Novo-Lac. Okay, in a number of hydroxymethyl phenol derivative you have taken, that's why all ring will join through CH2. Between the two rings CH2 will be there. Now after that I am talking about the bakelite. Now Novo-Lac you got, Novo-Lac you got. Now you will use this Novo-Lac for bakelite. From this you will get bakelite. Novo-Lac on heating with formaldehyde. Novo-Lac on heating with formaldehyde means HCHO. Also you can tell CH2OH, same things. Novo-Lac on heating with formaldehyde undergoes cross-linking to form an infusible solid mass called bakelite. Again I am telling you, Novo-Lac on heating with formaldehyde undergoes cross-linking to form an infusible solid mass called bakelite. It is used for making comps, COMBS, comps, daily you are using comps, and phonograph record. In that also it is used in phonograph record. Electrical switches means hard switch, have seen electrical switch, it will be hard. Then in electrical switches and handles of various utensils, these are the uses of bakelite. It is used for making combs, phonograph records, electrical switches and handles of various utensils in kitchen, you might have seen. Then now a structure is very simple for bakelite, because here you Novo-Lac plus formaldehyde now you require here. Actually all things will be the same. Now Novo-Lac was linear. Now here you will get cross linking, that's enough. Means two chain you will take. Then again both chain will join to each other, that also through CH2. Correct? Suppose two chain you have taken, then both chain will make link through CH2 only. Here also you will get CH2. Then now we will tell how. Then now I told you that this it will form in the beginning. You have seen that alpha position CH2O was there, para position also CH2OH was there, and again at 6th carbon again CH2OH is there. Then in three direction it can join with other rings. Correct? If same hydromethyl phenol is there, derivative, then now three scopes are there. It can join in three direction, left side also, right side also, per position also, because everywhere CH2OH is there. CH2OH is there, then OH is there. Then now again next chain it will join through the carbon having H. Carbon, you know that at each carbon hydrogen is there. Then where you can say CH2OH is not joined, that carbon has hydrogen. Then that hydrogen will join with react with OH, and it will form water. It will go outside. H will go as H plus, OH will go as OH minus. Then same way, when H will go as H plus, carbon will become negative. OH will go as OH minus. Then that carbon will become positive. Then this negative and positive carbon will join. Then in the middle only CH2 will remain between the two ring. Like that way, from each ring, first ring, suppose three ring was there in the first you can say chain. First chain, three ring was there. Down also three ring was there. Then they will join like that way, what I told in that way. H and OH will react and will go as water, and CH2, that carbon, and benzene ring, that positive carbon, both will join everywhere through CH2. Correct? Then both chain will make link, that is called cross linking. Okay. Then Novolac on heating with formaldehyde, more formaldehyde is required here. Only then you will get at alpha position, para position, and again 6th carbon, everywhere it can CH2OH can form. That's why more formaldehyde is required. Then this is actually solid mass, and it is called bakelite. Use already I told you, it is used in combs, phonograph record, electrical switches, and handles of various utensils. Now next polymer I am telling you, melamine formaldehyde polymer. This also will get through condensation polymerization. Okay, melamine formaldehyde both will join, and you will get the product that is actually called that name you can tell, melamine polymer. Melamine polymer, actually it is used in the manufacture of unbreakable crockery. There it is melamine polymer is used. Then reaction I am telling you, melamine formaldehyde polymer is formed by the condensation polymerization of melamine and formaldehyde. Then what is the structure of melamine? It is very easy to remember, very easy to remember. Here actually this is the 6-member ring first of all, and out of this 6 atoms, 3 atoms are nitrogen and 3 are carbon. Out of 6 atoms in the ring, alternate carbon and nitrogens are there, means 3 nitrogen and 3 carbon, correct, alternate. And on each carbon NH2 has joined, correct, on each carbon NH2 is there, means 3 NH2 is there at 3 carbon. Then it is very easy to remember that it is a 6-membered ring. In that 3 are nitrogen, 3 are carbon, and nitrogen and carbons are alternate, nitrogen then carbon, again nitrogen then carbon, again nitrogen. Okay, means first nitrogen then carbon, again nitrogen then carbon, again nitrogen then carbon. Unlike benzene ring, alternate double and single bond is there. Okay, and on each carbon NH2 is attached. 3 carbon is there, then at 3 carbon, all 3 carbon NH2 is attached. This is actually melamine. Then melamine plus formaldehyde means HCHO. Then here a reaction, how reaction will go, now easily you can understand, correct. Formaldehyde is there, HCHO. Then now NH2 of the ring melamine and HCHO is there. Then what will happen here, that H from NH2, it will go as a H plus, then nitrogen will get negative. H will go as a H plus from NH2, then nitrogen will get negative. Then after that what happened, this H, here also you remember that CH, formaldehyde, carbon and oxygen is double bond, then that bond will break, then O will become negative, carbon will become positive. Then this carbon, this positive carbon and a negative nitrogen will join, correct, and H plus from the NH2 it will join with oxygen which is negatively charged. Okay, O has negative, after becoming double bond will become single bond, then oxygen will become negative. From that H will join H plus from NH2, that will join to O which has negative charge. Then now O became OH, and carbon joined with nitrogen. Then now product you are knowing structure, it is very easy that now N will join with the C of CHO, then you will get NH is remaining in melamine, NH is remaining, and that CH2 has joined, C has joined, then that carbon CH2 was there, 2H was there, you can write CH2O, and with O H has joined. Then this is actually called resin intermediate. Actually melamine formaldehyde, actually it is a resin in real sense, resin. Then this is actually intermediate, resin intermediate. Now after that what will happen, only actually you should get polymer. Then if it will be in the same number, many n number. If this intermediate, resin intermediate, now suppose it is in n number, repeating unit, then what you will get here? Then easily you can write whole things you can write except OH, all things, because OH will go, all will join with OH only, OH bond has to go. Then CH2OH was there in the end, then OH will go, just CH2 will be open hand, valency will be the one, valency will be there, and this other side again NH2 was there, means sixth carbon, sixth position or sixth carbon, that is only 3 carbon is there, but I am talking about that sixth atom, that is carbon, from that NH2 is there, then also it can join from that side, hence there also the one valency it will be open. You don't write HNH2, you write only NH, and this side write only OH. OH you have to not write, only you have to write CH2 and open valency, and this you write in bracket you write, and outside N you write N. Okay, because it can join with wherever NH2 is there, in 3 direction it can join, left, right, and para position also NH2 is there, then this they can make link through this 3 position. Okay, wherever NH2 is there, from that side molecules can join. Then all 3 side you write only NH. 2 NH2 was there, you write only NH opened, one valence is opened for the making bond, and CH2OH side only CH2 you write an open hand, that to write in the inside the bracket, on outside you write a small n down. Then this is called melamine polymer. It is used in the manufacture of unbreakable crockery. Now next I am telling you about the copolymerization. Already I have given hint. Okay, copolymerization is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize and form a copolymer. Again you listen, copolymerization is a polymerization reaction in which a mixture of more than one monomeric species, means here monomer will be not the same, many are there, but all are not the same, all may be different. Okay, mixture of more than one monomeric species is allowed, then here all are not the same, all monomers are not the same, may be different. Then mixture of more than one monomeric species is allowed to polymerize and form a copolymer. Co means just like a colleague, friends, co which are always with you, co. The copolymer can be made not only by chain growth polymerization. Copolymer can be made not only by chain growth polymerization but by step growth polymerization also. Okay, it contains multiple units of each monomer used in the same polymeric chain. Monomers will differ. For example, a mixture of 1,3-butadiene and styrene can form a copolymer. Here both are different. One is 1,3-butadiene, you know that 4 carbons are there, 2 double bond is there, CH2CH, CH2CH. means first and second carbon double bond is there, and second and third single bond is there, and third and fourth double bond is there. Carbon number 1 and carbon number 3. Carbon number 1 means 1 and 2. Carbon number 3 means 3 and 4. Double bond is there. That's why it is called 1,3-butadiene, because 4 carbons are there. Then if you will take n number of 1,3-butadiene, and other monomer will be styrene. Styrene. What is a styrene structure? It is easy to remember. With benzene ring, when a CH2 means when ethylene will join with benzene, then obviously one H will go. One H will go from the CH2. Then that one H will go and one benzene ring will join with ethylene. With ethylene, one in the place of H, one benzene has joined. Correct? Then that is called styrene. Means with a benzene ring, CH2 has joined. Then CH and CH2 double bond is there. Styrene. Then now that this reaction actually already I have discussed, but now I am again telling you. Then here where will it react? Where will it react? Then you know that always bond will break. Always bond will break from the double bond. Then now that in a styrene CH and CH2 double bond is there, that will come closer to 1,3-butadiene. It will come closer to 1,3-butadiene. Then now in butadiene 4 are there carbons, and now these 2 carbon, total 6. Then that you write just reverse it, means CH2 write near the 1,3-butadiene, and styrene means benzene ring you can write as a branch upside. Then you can understand the reaction very easily. Then here that how reaction will take place, then I told you that in butadiene carbon third and fourth double bond is there, that bond will break. One bond will break, one bond will be there. Then both carbon third and carbon fourth will have one electron. Correct? And now this also, first and second also double bond is there, and one bond will break. Then again first and second will get one electron. Correct? Then here what will happen? Second and third also means second also have one electron, third also have one electron. Hence both can make a double bond. Then this was the single bond, and now it became double bond, because both electron form the one bond. Then now where single bond was there it became double bond, and where double bond was there it became single bond. Means carbon and first and second single bond, but first carbon have one electron, means one valency, and fourth carbon also have 3 and 4th have only one bond, but fourth carbon have one electron. Then same thing will happen here in a styrene. CH2 double bond is there, then that bond will break, one bond will break. Then one carbon will get one electron, other will also get one electron. Then now you can see what will happen, that this CH attached to the benzene ring. Benzene you are writing upside. Then that carbon which is attached to the benzene, now benzene is upside, you remember, and that carbon will have 1 electron, and last carbon also have 1 electron, means as styrene 2 carbon is there, both have 1 electron. Then second carbon have 1 electron, that will be, and the end it will be opened valency. Then now this carbon which is joined with the benzene ring, it has 1 electron, and fourth carbon of the butadiene, that also have 1 electron. Both will join and will make a bond, means now a styrene and butadiene, 1,3-butadiene joined. And what you got product, that is actually butadiene styrene copolymer. This is called butadiene styrene polymer. Then this is the repeating unit, because both end is opened. Correct? First carbon and last carbon here means of styrene. From that side again both sides can join. Hence it is a repeating unit. You can write in bracket. Outside you can write down N. This is actually butadiene styrene copolymer. Here both monomers are different. Copolymers have properties quite different from homopolymer. Homo means same. Like polythene. All were ethylene only, polythene. And their properties different, and copolymers properties are different. Copolymers have properties quite different from homopolymers. For example, butadiene styrene copolymer. Here styrene in shortcut S, sometimes S is written S. S means styrene. Then butadiene styrene copolymer is quite tough, means hard, tough, and is a good substitute for natural rubber. Okay, it is a tough. Butadiene styrene copolymer is quite tough and is a good substitute for natural polymer, a natural rubber. Okay, substitute for natural rubber. It is used for the manufacture of auto tire. Tire you have seen everywhere. Auto tire means a common tire in you have seen in the car, in the auto, correct? That tire I am talking about, tractor, because it is a tough for that purpose. Then it is used for the manufacture of auto tires and floor tiles, footwear components, cable insulation. Here these are used. Importance of butadiene styrene copolymer. It is used for the manufacture of auto tires, floor tiles, footwear components, and cable insulation. Foot, you have seen that in shoe, particularly that for the sports shoe, there it is used. Footwear components, cable insulation. You know that on wire some rubber will be there, correct? Then that is actually cable, that is for insulation purpose. That's why it is called to cover the wire. Cable insulation, correct? Cover. This is a non-conductor. Hence you can touch it, nothing will happen. Now I am telling about the rubber, natural rubber. Okay, next thing is rubber, natural rubber. You should know, always you are using rubber, that is natural rubber. Rubber is a natural polymer and possesses elastic properties. It is also termed as elastomer. Already I have given these things hint in the beginning, introduction time. Rubber is a natural polymer and possesses elastic properties. It is also termed as elastomer and has a variety of uses. It is manufactured from rubber latex, 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 which is a colloidal dispersion. Okay, this is a rubber is manufactured from rubber latex. What is the rubber latex? Then this is a colloidal dispersion of rubber in water. Remember it. Rubber latex is a colloidal dispersion of rubber in water. Means rubber plus water, you can tell. Colloidal dispersion of rubber in water. This latex is obtained from the bark of rubber tree. There will be rubber trees. Okay. That one tree is there, their bark. From that you will get latex. This latex is obtained from the bark of rubber tree and is found in India, Sri Lanka, Indonesia, Malaysia and South America. These trees are common. Again, I am telling you, it is found in India. Rubber tree is found in India, Sri Lanka, Indonesia, Malaysia. All these 4 countries are close. Correct? Sri Lanka, I know it is near to the India only. Indonesia is near the Sri Lanka. Malaysia is also near that. Only America is far. South America. Natural rubber may be considered as a linear polymer of isoprene. Always remember, question is asked. Natural rubber may be considered as a linear polymer of, remember, isoprene. What is isoprene? Then it is the 2-methyl-1,3-butadiene. Then butadiene, you know, 1,3-butadiene. But at carbon number 2, if methyl group is attached, then that is called 2-methyl-1,3-butadiene. This is actually isoprene. And this isoprene is a unit. This will be repeated always. Isoprene unit will be repeated. Then you will get polyisoprene. Correct? This is actually natural rubber. And is also called Csir-1,4 polyisoprene. Okay. And it's a structure you can understand very easily. That is natural rubber structure. I am telling you that I told you that at carbon number 2 methylene group will be there. Methylene group, methyl is CH3 group, you remember. Methyl group is CH3 but methylene group is CH2, only CH2, and one open valency will be there to join with other. Whenever CH2 will be there, then both side one open valency will be there to join. There already one valence is joined with the carbon 2. Then CH2, that is called methylene, because it came from the methyl. H has gone, then CH2 will remain with one valency, because one electron will be left out, when hydrogen will go. Then at carbon number 2 methyl group is there. 1,3-butadiene, you know, that CH3, CH2, second carbon CH2 is attached. Then here actually it was the double bond, now it became single bond. Okay. Then from this second carbon CH2 is attached, and second and third carbon has a double bond. You remember. Correct? Here that 1,3-butadiene 1,3-butadiene structure first to write. C, that is the CH2 1 3 means carbon number 1, carbon number 2, double bond is there. Carbon 3rd, carbon 4, double bond is there. Correct? In the middle, single bond will be there. Means first and second double bond. Then and third and fourth is double bond. Then second and three single bond, only one hydrogen is there. Then now here with carbon number 2 methyl group is attached. Only this you remember. And carbon number 4th has joined with other 1,3-diene. It has joined. Understood? Then now because second and fourth was having double bond, but when double bond will break, then what will happen, you know? Each carbon will take one electron, then second and third will become double bond, and first and third that will become single bond. And after that one electron will be there, then one electron third and second used to make the bond. But first carbon, that is open valency, CH2 we are writing, and fourth CH2 is there, but one electron is there. That will join with other. That will join with other isoprene, means 1,3 isoprene you can tell, because CH3 is attached. Then now first unit will join with the second unit of isoprene. Second will join to the third will join to the fourth. Like that way you will get a chain, and the end open chain will open, valency will be there to join for others. This is actually natural rubber. Now isoprene formula already I told you, CH2 carbon first and second, double bond is there, second and third single bond is there, and third and fourth double bond is there, and with carbon number 2 CH3 is attached, because in that was a CH actually, carbon second had CH, in the place of that H CH3 has joined. CH3 joined with second carbon in the place of H, correct? Then third carbon has CH, H1H, and after that third and fourth double bond is there, that is the CH2. But this is actually isoprene unit. But if you write for joining purpose, means for making a polymer, that time all double bond will become single bond, and second and third will become a double bond. You remember. This is actually when a natural rubber I am talking about. This is actually Csir polyisoprene. Correct? Because CH3 is attached, that's why iso word has come. And many have joined. That's why it is called Csir polyisoprenes. Csir and adjacent, you know, in the same side. If opposite group is opposite, that is called trans. If adjacent means Csir. Then Csir polyisoprene molecules consist of various chains held together by van der Waals interaction force. That is also called force, van der Waals force. That's Sorry for interruption. I was talking about the Csir polymer, this Csir isoprene molecule. Okay. Then the Csir isoprene molecules consist of various chains held together by weak force called van der Waals interaction and has a coiled structure. You remember, coiled, it's like a coil. You can make it long also, coil. Then it has a coiled structure. Thus it can be stretched like a spring and exhibits elastic properties. Now you can understand why rubbers are stretching, because it has coiled structure. Hence if you apply force, it will become longer. It can be stretched. Now this vulcanization of rubber I will discuss. Vulcanization of rubber, question is asked. What is the vulcanization of rubber? Question is asked. Then it actually you will get from the natural rubber only. Natural rubber becomes soft at high temperature, greater than 335 Kelvin. It will become soft and brittle at low temperature, below 283 Kelvin. It is in Kelvin and temperature will be less, only below 283 Kelvin, and will become soft when you will heat it. Rubber you will heat, what will happen? You can understand also. It becomes soft. Then soft at a high temperature more than 335 Kelvin, and brittle at low temperature 283 Kelvin, and shows high water absorption capacity. It absorbs water. It is soluble in non-polar solvents. You remember, it will not dissolve in non-polar solvents. Polar solvent something will happen. It is soluble in non-polar, means organic solvent, it will dissolve, not in polar. Okay, and is non-resistant to attack by oxidizing agent. No effect of oxygen, means oxidizing agent. It is a non-resistant, and this I am talking about non-resistant to attack by oxidizing agent. Okay, non-resistant, no resistance, means oxidizing agent can attack. Oxidizing agent, it will have effect with oxygen, non-resistant to attack by oxidizing agents. To improve upon these physical properties, a process of vulcanization is carried out. To improve these properties, because it is going to be affected by oxidizing agent. Okay, to improve upon these physical properties, a process of vulcanization is carried out. This process consists of heating a mixture of raw rubber with sulfur. Here you have to do treatment with sulfur. It consists of heating a mixture of raw rubber with sulfur and an appropriate additive at a temperature range between 373 Kelvin to 415 Kelvin. This temperature you have to maintain. 373 to 415 Kelvin means 115 degree, you can tell, 115 degree. But in Kelvin, 373 to 415 Kelvin. 373 means 100 degree, 215 degree. 415 K you have to maintain, means 215 degree, and in Kelvin 373 to 415 Kelvin. Okay, on vulcanization, sulfur forms cross links, role of sulfur. It will, on vulcanization, sulfur forms cross links at the reactive sites of double bonds. Okay, sulfur forms cross links at the reactive sites of a double bond, and thus the rubber gets stiffened. Rubber gets stiffened. In the manufacture of tire, about 5% of sulfur is used as a cross-linking agent. Here I told you one additive is required. Then here that is a 5% of sulfur is used as a cross-linking agent. The probable structure of vulcanized rubber molecules, I am telling you that here that rubber structure, you know, two chain you can take, two chain, and between the two chain sulfur will come. Then sulfur will join both chain. Okay, sulfur will come in the middle and it will join with two carbon. It will join with two carbon. In the middle sulfur will be there. Means wherever carbons are, the carbon chains, this isoprene chains will be there. Then always between the two carbon sulfur will come. Okay, always means just it will come one chain and other chain. Then both chain in parallel it will run. Then between the two carbon sulfur will come. Sulfur will make bond with S and C one side, other side also S and C. Then on each carbon means wherever possibility is there, you have to maintain the this things valency, tetravalency of carbon. Then wherever possibility is there, it will make link through sulfur. Okay, and whenever it will make link, that carbon you have to think whether valency is 4 or not. If not 4, then it will not join. Always it has to maintain tetravalency of carbon, because now second carbon you think one side already CH2 is there beginning, and second it is attached with the CH3, and that carbon is attached with the next CH in the chain. Then fourth one, that was the CH, that H has gone and S has joined. Same thing will happen with the third carbon. Third carbon means wherever a scope is there, it will make join through sulfur. Okay, then this is actually called vulcanization. Now, what is actually synthetic rubber? Synthetic rubber, this is a natural, and you have done vulcanization of rubber. But what is a synthetic rubber? Synthetic rubber is any vulcanizable rubber. Okay, vulcanizable rubber like polymer. Synthetic rubber is any vulcanizable rubber like polymer, which is capable of getting stretched to twice its length. Means it can stretch double. If 5 centimeter they are there, then it can go up to 10 centimeter. Okay, it can be stretched up to 10 centimeter. If it is a 5, double. Then synthetic rubber is any vulcanizable rubber like a polymer, which is capable of getting stretched to twice its length. However, it turns to its original shape and size as soon as the external stretching forces is released. Again it will come to the original position, small only. You can make it 5 centimeter there, 10 centimeter. If you will relieve the force, again it will come original, 5 centimeter only. Thus, synthetic rubbers are either homopolymers of 1,3-butadiene derivative, or it is a homopolymers as well as homopolymers of 1,3-butadiene derivative, means only it will be repeated, only one monomer. Also can be copolymers of 1,3-butadiene or its derivative with another substituted unsaturated monomer. One will be 1,3-butadiene, other will be unsaturated monomer. Unsaturated means having double bond or triple bond. Okay, only then it can join by breaking the bond, one bond. That's why unsaturated monomer is required. One will be required 1,3-butadiene, another will be unsaturated monomer. Then both will join. Okay, then it by homopolymers also can be formed and by copolymers also. Then now example is neoprene. Synthetic rubber example is neoprene. Neoprene also called polychloroprene. Already I have given example previously. This structure also I have sent. Polychloroprene. Okay, neoprene is also called polychloroprene. Okay, neoprene or polychloroprene is formed by the free radical polymerization of chloroprene. Okay, polymerization of chloroprene. Chloroprene means what? That now it is a butadiene. Butadiene. Only thing difference is that at carbon number 2 Cl is attached. Okay, isoprene you have seen CH3 was attached, but here Cl is attached. And this is called chloropene. Chloropene, that time it was isoprene when CH3 was attached. Now Cl is attached, then it is called chloroprene, means 2-chloro-1,3-butadiene. It will repeat. Suppose n numbers are there, n number of chloroprene is there, then double bond will become single bond, you know, and where single bond was there, that will become double bond. It means carbon number 2 and 3 will be double bond. It was single, now it became double bond. Carbon number 1 and 2, that was a double bond, became single bond. And third and fourth also it was double bond, that became single bond. Then first carbon and last carbon will be opened valency. Okay, then this unit will repeat. In bracket you write, and down you write n, a small n. Then it's called neoprene. It has superior resistance to vegetable and mineral oils. Listen here, it has a superior resistance to vegetables and mineral oils. It is used for manufacturing conveyor belts, gaskets and hoses. This is the use. It is used for manufacturing conveyor belts, gaskets and hoses. Okay, now second example I am telling you, Buna N. Buna N. N means here nitrogen, cyanide will be there. Okay, that's why Buna N. N means here cyanide is joining, N is there. Already I have discussed this. Buta N is obtained by copolymerization of 1,3-butadiene and acrylonitrile in presence of peroxide catalyst. Already I have discussed. Then if we will take 1,3-butadiene in n number, a small n, and acrylonitrile also in n number. Acrylonitrile, I told you that ethylene molecule is there, from that one H will go and at its place Cn will join. Then CH2 double bond was there, you know, ethylene. Then double bond will be there, but H will go and at its place Cn will join. This is called acrylonitrile. Then now suppose this is also in n number. Then now both will join. Then where it will join? Now you are knowing, wherever double bond is there, that will become single bond, and each carbon will get one electron, correct? And same way only to first and second carbon, that also will double bond is there, will break and will convert to one single bond, then both carbon will get one electron. Then in second and third carbon they will make a double bond. It was single, now it became double. Then now carbon 1 and carbon 4 has single electron. Then butadiene, this carbon 4 has single electron, and now that in acrylonitrile that double bond will break, then that both carbon will have CH2 and CH, that will have one electron. Then now you are understanding that this carbon also has one electron, butadiene fourth carbon also have electron, both will join, and what you will get, that is the Buna N. In acrylonitrile double bond became single bond, correct? But with the second carbon of acrylonitrile, that has CN, then first carbon and last carbon, that will be opened, okay? Valency will be there, both have one electron. Then now this is the unit, repeating unit, complete. This is the one unit what you got, that is the Buna N. Then you can write this unit under the bracket and down you write a small n. Then it is resistant to the action of petrol. Now no effect of petrol. It is resistant to the action of petrol, lubricating oil and organic solvents. No effect. It is resistant to the action of petrol. No effect of petrol, lubricating oil and organic solvents. Where it is used? It is used in making oil seals, tank lining, etc. Okay. Now I am stopping only here. Next class little things are remaining. I will discuss next class. Okay, thank you.